Welcome back to yet another exciting session of algebra, and today we'll be taking up polynomial, chapter 2 of NCERT. Now let us see what we have to study in polynomial. Before we study polynomial, we have to recall certain things. Let us recall the expressions or the algebraic expressions that we have done in our previous classes. What are algebraic expressions? Algebraic expressions, which we simply called expressions, they are combination of literal numbers are nothing but the alphabets, English alphabets, letter of the English alphabet which are used as symbol, which denote unknown quantities like x, y, z. So literal numbers are nothing but letters of English alphabet and they denote unknown quantities. Literal numbers plus, I would not say plus, it's a combination of literal numbers plus constants. So constants are numerical values. These literal numbers, they are known as variables. Why do we call them variables? Because they take different values in different situations. Let us start with an example of an expression, 3x plus 5. It's an algebraic expression because it's a combination of a variable and a constant. It's a combination of a variable and a constant, and the sign in between is plus. So whenever we have a plus or minus sign between two numbers, it separates an algebraic expression into terms. So here the first term of the expression is 3x. 3x is the first term of the expression and 5 is the second term of the expression. Now, why do we call them first term and second term? How do we know that these are the two separate terms? This plus sign. So terms are separated by a plus or a minus sign. Terms are separated by a plus or a minus sign. In 3x, this x and 3. When I am writing 3x, in 3x, this 3 and x, they are not separate terms. These two are not separate terms because we do not have a plus or a minus sign between them. 3x is nothing but 3 multiplied by x. So, whenever we have a multiplication sign or a division sign between two numbers, one of which could be a constant, other could be a variable, or both of them can be variables, then they are not treated as separate terms. 3 is the coefficient of x. So, a number, a variable which is multiplied with a constant, the constant value is the numerical coefficient of the variable. So, this was all about the recap of expressions. Let us quickly move to types of expression before we move on to polynomial. A constant expression. What is a constant expression? A zero expression, a monomial, a binomial and a trinomial. Let us first start with this. A constant expression is nothing but a constant term, a single number. So, one term consisting of a constant value only. When I am talking about a zero expression, which we will also later will call it a zero polynomial, it has only one term which is 0. Monomial will also be a one termed expression, but it may not be a constant value, it may not be a 0, it can take other values like 3x, 4yz, 6xyz or 4. Even a constant expression, which will be, we will later know why it is called a polynomial, is also a monomial because it is having only one term. Both constant and 0 expressions are my monomial. Binomial, when I will have two terms, it is called a binomial, and I explained that how do we know that an expression has two terms. As soon as I see a plus or a minus sign between two numbers, 3x plus 4y, in the expression 3x plus 4y, 3x is a separate term and 4y is a separate term because in between we have a plus sign. Had it been 3x into 4y, then it would have been considered a single term. A trinomial similarly will have three terms, ax plus by plus c, where ax is the first term, by is the second term and c is the third term. Now, let us move to polynomial. What is the meaning of the word polynomial? Polynomial, the word polynomial is divided into two parts. The first part is poly, which means many, and the other word is mial, which means terms. So, together if I combine them, the word polynomial altogether means a many termed expression. So, whatever expressions we have learned till 3 terms or 4 terms, we expand it further till n terms to study polynomial. So, if I go back to the previous slide, a constant polynomial is a polynomial having only one term which is a constant value. A zero polynomial is again a polynomial which is also a constant polynomial because 0 is a constant number having the value 0. A monomial is a single termed polynomial, binomial 2 termed and trinomial 3 termed. We may have a quadrinomial having 4 termed expression. Polynomial expressions. As I told you, a polynomial expression consists of variables and constants, where variables are determinants or coefficient. Coefficients like if I have 3x, if I have 3x as one of the terms, then x is the coefficient of the term. It is a variable coefficient of the term. It is also a determinant and coefficient. So, a variable term will consist of a determinant and a coefficient, constant value, fixed values like 2, 4 and 9 and so on. We may have a variable coefficient x in 3x and numerical coefficient as y in 3y. Now, let us come to the general definition of a polynomial. I may have a one term polynomial, I may have a 2 term, 3 term, 4 term, and I may have an expression till n terms. So, how do we generalize the thing? A polynomial fx in general is a function in x. Now, what do we mean by function in x? When I am talking about function in x, that means x, my variable x, is behaving in a certain way, and here x is considered to be an input which when put in a certain machine will work in a proper way. It will work in a defined way. So, what is that defined way? What is the function? For example, if I write 3x plus 4, which is a polynomial, why is it a function? This is called a function in x. Now, why it will be called function? Because x is behaving in a certain way. X is my input, and if I put this input, if I function this input in a certain way, what is that way? What I did to get this 3x plus 4. Starting with my input x, I multiplied x with 3. This is the process. How is the machine functioning? And then after multiplying it with 3, I get 3x. Now, this 3x to this 3x, 4 is added. After 4 is added, we finally get the final output 3x plus 4. So, this is my final output when the input is x. So, since it is a polynomial, and we can see that we obtain the polynomial by taking x as the input and processing it using some mathematical operation and finally getting an output, we get the function in x. That is why a polynomial is also known as a function in x. A polynomial fx in general is defined as a function in x where x is the input. Let me explain what is the meaning of a function. When I am saying that x is an input in an expression, suppose the function in x, which is an expression, is defined as 3x plus 4. Now, 3x plus 4 is an expression, but how did we get that expression? How is x behaving? That is, processing of x is done in what manner? We started with an input x. We first multiplied it with 3. As I multiplied it with 3, I got 3x. Now, this 3x to this 3x, further 4 is added. When 4 is added to it further, we finally get the final output 3x plus 4. So, starting with the input x, I get the output which is also known as function in x. So, output is fx and the input is x. Now, why is a polynomial known as a function in x? Because be it a one-termed expression or two-termed or three-termed or a n-termed expression, x will behave in a certain way. X will be multiplied with something, or something will be added to x or subtracted from x. That means some mathematical operations will take place with x and will get an algebraic expression. It is written in the decreasing power of x and the last term is a constant. Let us see how. Fx is written as a combination of number of terms with either a plus or a minus sign in between. We generally take the plus sign because the minus sign arises because of the constant value. So, this is generally how do we write a function or a polynomial. Carefully look at the expression. Here the first term, if it is an n-termed expression or a polynomial comprising of n terms, then the power of the variable in the first term is n and the last term, and it is gradually decreasing. If the power of the variable in the first term is n, the power will be n minus 1 in the second, n minus 2 in the third, and n minus n, that is 0 in the last. So what we will have eventually, that a raised to an, that is the nth constant multiplied with x raised to the power 0, and we know any variable or any number raised to the power 0 is always 1. So my last term eventually becomes a constant. So always remember, be it any polynomial, the first term will be the highest degree or highest power, will carry the highest power of the polynomial, and the last term will be a constant term. What are the other properties? What are this a1, a2, a3? What is the property of x, and what is the property of n? N is always a positive integer. That means the power of x has to be positive. If the power of x becomes negative, then it takes the form of reciprocal and it will no longer be considered as a polynomial. And this a1, a2, a3 are all constant values which can be positive, negative, or a fraction. It can be any, all constant values. Most important thing here, in a polynomial, x cannot be 0. Then you may ask me a question. It is not necessary that every polynomial will have equal number of terms, right? If there are 2 terms or 3 terms or 4 terms, or if the why are they so if I have nth term? If a term becomes 0, that is not because x is 0, that becomes 0 because the constant value may be 0. Let us start with polynomial, taking few examples and understanding polynomial better. Let us start with an example to make you understand polynomial better. Suppose we have a polynomial fx as 3x cube plus 2x square minus 5x plus 6. I have written this polynomial in decreasing power of x. As we can clearly see, the highest power is 3, then we have a power 2, then we have power 1, and then we have 6 with x raised to the power 0. I can also write fx as 3x cube plus 6. Now this is also a polynomial written in decreasing power of x, but you may question me, where have these two values vanished? And I mentioned x is not equal to 0. If x is not equal to 0, then how come these two values vanished? If x would have been 0, then obviously the first term would also have been 0. These two values vanished because here in the first example, these two constants were 2 and minus 5. X square was multiplied with 2 and x was multiplied with minus 5. But in the second example, if I rewrite the second example, this is example 1, this is example 2. If I rewrite the second example, I may write it as 3x cube plus 0 into x square plus 0 into x plus 6. Now there were no terms in between because the coefficient of the second and the third power of x was 0. So this clearly explains that if there are less number of terms in a polynomial and if all powers do not come in continuation in decreasing order, this is just because the constant values have been 0.
To watch the complete video, download the Upbind educational app from Play Store and App Store.